Math. All right, ladies and gentlemen, we are going to review exponent properties. You should have your note taker that says Exponent Properties Review for Module 6. And we're going to first start with some key terms that we need to have memorized. So we're going to write these down. So the first term is a product of powers. So when you multiply exponents with the same bases, this is important. They have to have the same bases in order for this to work, or else you can't do what we're showing you right now. So when you multiply with the same bases, you add the exponents. And like we showed in class, or you may remember from previous grades, the reason for that is because if I have, here, we'll do this one down here, 5 to the second power, that's 5 times 5. If I also then have 5 to the fifth power, that's 5 times 5 times 5 times 5 times 5. If I multiply all of these together, that is now 1, 2, 3, 4, 5, 6, 7 fives. 1, 2, 3, 4, 5, 6, 7. And that's going to make 5 to the 7th power. So the easiest thing for you to do, instead of doing what I just did, is just to add those exponents and keep the base the same. Don't forget, though, that when you have a base here, or a power, or a variable that has no power, or even a number, its power is automatically 1. Okay, so that is technically a 1 for you to add. So 4 plus 7 plus 1. And just as a reminder, you have spots on your note takers. You should be writing down these definitions and examples. You write down whatever you need to understand it. If you want to write the words and the examples, go ahead. If you want to write the real examples and not just the general examples, do that. If the general example helps you, it's up to you. All right, so our next property is the property of the quotient of powers, so quotient being division. So when dividing exponents with the same bases, you subtract the exponents. And it's the same problem as we had before. If I have 8 sixes, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, they're not pretty. But I'm dividing by 3 sixes. Any number divided by itself is 1. So those kind of cancel out. And I'm left with just, whoopsie, the 5. And that's why you would get 6 to the 5th power there. Or you can just subtract your exponents. Our next, awesome. Our next power property is power of a power. So it's when you have the parentheses and you have an exponent and then immediately another exponent on the outside. When you do that, you multiply. Okay, so again, the example would be like 2 to the second raised to the second. Would be I have 2 of these raised together, okay, 2 times because it's 2, or if it was 3 times, I would be multiplying by 3, whoopsie, 3 times, let me erase that, there we go. And so in that case, because I'm adding these 3 times, or it's the same thing, it's repetitive addition, which is the same thing as just multiplying 2 times 3. Okay. Our next term is power of a product. So when I have something inside my parentheses, I am multiplying, and all of that is being raised to another power. I am basically just distributing this m and giving it to both of the objects in the middle. I'm multiplying. So a times b raised to the m power is the same as a to the m power times b to the m power. So you can see this here. I'm going to give the 3 to the 5 and to the 6. So I would have 5 to the 3rd times 6 to the 3rd. And because my bases are not the same, I can't actually do anything here. I'm not going to add these exponents. I would physically have to do 5 to the 3rd power, which is 125, 6 to the 3rd power, which was 6 times 6, so 36 times 6, and I'd have to actually multiply those together. So 216, and I would multiply those together. All right, negative power. When you have a negative exponent, we make it a fraction. Now, this is the generic rule. You do not need to know why this happens. You can just memorize it. But I find that it does help. So as you saw in class, if I have 6 to the 4th up top, and on bottom I have 6 to the 6th, my properties say, because I'm dividing, I'm going to subtract. 4 take away 6 is equal to -2. And that's because if I have 4 6s, I'm going to end up with 2 6s on the bottom here. If I were to cross those out, 6 times 6 times 6 times 6 over 1, 2, 3, 4, 5, 6. Cancel them out, and I'm left with just 2. So that is the same as 1 6 to the 2nd, which is the same as the negative. Okay. What that also means is that if you have a fraction like this, you're just flipping it upside down. So a negative third power, I'm going to give it to both the 2 and the 3. But the negative means I am flipping, my base becomes my denominator becomes my numerator, and my numerator becomes my denominator. So it's going to become 3 over 2, and both of them are to the third power. And then I can actually show, oh no, sorry, that's 27. I haven't done my squares and cubes in a while, and that's 8. And so then you would have 27/8 to deal with. All right, for our 0 exponent, so as long as your base is not 0, this works. But if you are raised to the power of 0, it is 1. And this explanation is very similar to some of the ones we've done before. But basically, if I have 6 to the third power divided by 6 to the third power, my division property says I would subtract. And 3 minus 3 is 0. What we also know is any number divided by itself is 1. So therefore, this also has to be 1, right? So if 3 to the third power over 3 to the third power is the same as 3 to the third power minus 3, 6 to the third power, 6 to the third power. So if all of this is equal to 0, 6 to the 0 power, and all of this is equal to 1, then we know that 6 to the 0 power is equal to 1. And again, it's something you can just memorize, but this is the reason behind why. All right, that is our examples there. So we're just going to go through these examples here to make sure we understand all of them, and then I'm going to let you practice on the back. So here is, and again, you need to memorize these properties. So this is the property of multiplication, which means I'm going to add. So I'm going to add my exponents and get 5 to the 7th. If you want to pause the video right now and do these on your own and then play and check your answers, you can do that too. Here I'm dividing, so my property says I am the quotient of powers, the property of division, says I'm going to subtract. 8 minus 3 is 5, so 6 to the 5th power. Here's my power to another power, so I'm going to multiply. 2 times 4, which is 8, 7 to the 8th power. Here is a negative exponent. That means it goes into a fraction form. So I'm going to turn it into a fraction with my denominator exponent becoming positive. Over here, I have product, power of a product. So I'm going to give that 3 to both the 6 and the 5. So you would have 5 to the 3rd times 6 to the 3rd. And then you could multiply that out like we said. Here is the same sort of thing, power of a product, except we have power of a quotient, but because it is negative, we are going to go ahead and flip this fraction. So you could almost think it's like this. And then because these negatives flip them to the opposite side of my fraction bar, it's going to become 3 to the 3rd over 2 to the 3rd. Okay, now when you're doing these problems, I'm being a little lazy here, but you do want to multiply them out if you can. I mean, I'm okay if you leave them like this, okay? But when you have something like this, you probably want to multiply them out so you can get a number answer. So let me do that here. Hold a second. Okay, so I kind of multiplied some of my things out here. All right, for our next one, even though we have 3 terms, I'm still just going to add each of my exponents, knowing that this guy has an exponent of 1. So it's really 4 plus 7 plus 1. So that is 7, 8, 9, 10, 11, 12. Okay. All right, now this is where it gets a little bit complicated. You are putting multiple properties together in one. And to be honest, I think these are super fun because they're kind of like puzzles, and you have to follow the order of operations on top of the fact that you have to follow your properties. So to solve a problem like this, I'm going to start by distributing this 5 to both of the terms inside. What I could also do is, I guess, solve this. Sometimes you can't solve, so let me actually back up. Reevaluating, I would solve first. If this was a variable term, then I'd have to distribute only. But because I can do 5 minus 2, which is 3, I know that's to the 5th power. I'm then going to multiply it by 3 to the negative 8. I'm going to leave that alone right now. Let's finish solving everything else. 5, 6, 7 to the 0 power. Okay, that was my first step. So I did this first, and then I just brought this down, and then I did this. Now, these two I know can go together, and when I multiply, I add. So I'm going to do 3 to the 5th plus negative 8. Now, this guy here, anything to the 0 power is just 1. So now I have to solve here. 5 plus negative 8 is negative 3, so I have 3 to the negative 3rd plus 1. So that's going to go ahead and make 1/27 plus 1. And my final answer is 1 and 1/27. So you're following order of operations, but you're also following your properties of exponents and just kind of rewriting and simplifying your expression each time until you get a solution or as simplified as you can go. This last one here, I've got multiple parentheses, so I'm going to do my inside parentheses first. Okay, so that's going to become 4 to the 2nd power to the 3rd power. 7 take away 3 is also 4 to the 2nd power. Now I'm going to solve my power to a power, so I'm going to do 4 to the 2nd times the 3rd. So this is 4 2 times 3. So that becomes 4 to the 6th. 2 times 3 is 6. Over 4 to the 2nd. Now I can subtract because my bases are the same. And I get 4 to the 4th power. And you could simplify that even more and tell us that 4 to the 4th power is, I believe, 64, if I'm done it correctly. I'm going to steal up the cheat and get a calculator out right now. I'm going to go 4 times 4 times 4 times 4. Oops, no, that's not right. So 4 times 4 times 4, that's 64. Yep, nope, 256. So that's wrong. 256. Okay, so take this information and go ahead. You have practice problems. Some are a little bit basic. Some are more complicated. Okay, some get super complicated. But what I want you to do is just practice these on the back of your worksheet. And we'll talk about it and go over it tomorrow in case you have any questions.